Hey y'all, today we're going to take a look at electrochemical cells in a more quantitative approach. We're going to do some stoichiometry. We're going to use the equation that we learned in the last video from Faraday's law, and we're going to go ahead and apply it today in this video. Let's go ahead and get started. So a quick review of the equation we learned in the last video. I equals Q over T. I is current in the unit amperes or amps. Q is the unit coulombs, which is basically like, if you want to think about it, chunks of charge, okay? And T is time in seconds. So this equation here can be utilized to be able to do conversions and dimensional analysis as we go through these problems. So it's one to have in your back pocket. Remember, it's on the formula sheet, so you don't have to memorize it. So let's just jump right in with a practice problem. In this problem, I have an electrolytic cell that is running for 2 minutes at 0.5 amps. And I want to know how many coulombs would have passed through that system during that time. In order to solve this, I'm going to use my I equals Q over T equation. I, in this case, amps, is 0.5. Q is what we're looking for, coulombs. And T needs to be in seconds. So we need to convert from minutes to seconds here. 2 minutes is 120 seconds. So over these 120 seconds, I would have gotten 60 coulombs because we take that 120 and we multiply it by the 0.5, which is the number of amps, and there we get our coulombs, 60. Now, some of these problems can actually be pretty complicated. And in doing so, we're going to have our longest and widest dimensional analysis setup of the year. So let me just show you kind of how we're going to set up a dimensional analysis grid. There's really two ways. The first way, and the way that I recommend, is you start with whatever unit you want to finish with at the top. For instance, if I want to finish with coulombs, I'm going to have my first unit at the top be coulombs. And then I'm going to try to cancel out everything else. If I want grams at the top at the end, if I need to finish with grams, I'm going to have grams starting at the top on the left side of my dimensional analysis grid. In the end, this helps because it makes sure that our final answer is in the units we need it to be. We're just going to cancel out every other unit that we have from the beginning. You could alternatively put that X or that unit anywhere within the setup, but there are risks there. The risk is that sometimes it's going to be on the bottom, which means your end answer is going to be the inverse of what it should have been. The other thing within these dimensional analysis grids is because we're going to have so many different unit conversions, you need to be really primed for all the different things that you can use. Conversions of time, using molar mass, amperage, right? Understanding that Faraday's constant, 96,485, which is going to be the number of coulombs per mole of electrons. That's on your formula sheet as well. A lot of different unit conversions available to us, and knowing which one to use and when is going to be important. In order to do that, you're going to have to do a unit analysis. Figure out what units you have and what units you need to cancel to make sure you end up with a unit of the answer. So let's just jump in with a practice problem here. In this problem, we're going to be looking for how many grams of solid copper is plated out or reduced or deposited at the end of 3 hours in this electrolytic cell. The first thing I'm going to do in this problem is I'm going to start with the unit I need to finish with at the top. This is going to be grams of copper. So remember, plating out means turning solid, all right? And we're looking for mass, grams. So we want mass of solid copper. So I'm going to have some unit with grams of copper at the top. So what unit or what thing could I use that has grams of copper in it? Well, the answer is molar mass. So I can use 63.55 grams of copper per mole of copper. And I'm going to start with that. I'm going to start with the grams at the top. Then I need to cancel moles of copper. How am I going to do that? Well, I have the charge of copper, 2 plus, here in front of me. So what I can do is I can cancel out moles of copper by using moles of electrons per mole of copper. To reduce copper, 2 plus, I need to add 2 moles of electrons. So I know there's 2 moles of electrons for every 1 mole of copper. That's going to mean I'm going to divide by 2 moles of electrons and multiply by 1 mole of copper. Next step, I have moles of copper that need to be canceled, or moles of electrons that need to be canceled. The unit I can use to do this is actually the constant 96,485 coulombs per mole of electrons. I'm going to divide by that. So I have 96,485 on the bottom, and I've got 1 mole of electrons on the top. That's going to cancel moles of electrons. But now I have coulombs. Need to cancel coulombs. Luckily, I had amps. Amps, if you remember, 2.5 amps means 2.5 coulombs per second. So I'm going to multiply by 2.5 amps. All right, I'm going to actually break that into its basic units, coulombs per second, 2.5 coulombs per second. But now I have seconds. I need to get rid of that. Well, luckily I have minutes. So I can cancel seconds and go to minutes using 60 seconds per minute. Then I can get to hours, 60 minutes per hour. Then I know we ran for 3 hours, so I can just use 3 hours as my simple unit. All right. Remember, not everything has to have something on the top or on the bottom. Sometimes with a unit conversion, you can just have a basic unit, a simple unit. 3 hours is my simple unit. Now, by canceling out hours, you can see I've canceled everything except for grams of copper. And if I multiply across the top, and if I divide across the bottom, I get that I deposited 8.89 grams of copper in these 3 hours. In this next practice problem, we're going to do a little bit more complicated way of setting it up, but just to prove to you that you can set it up in different ways. Here, I'm going to start with my simple unit, 2.43 grams of silver deposited. But I don't really have anything to cancel yet. So what I'm kind of doing here is I'm setting it up in a way that's more guess and check style and not a little bit more defined. So what I'm going to then do is say, okay, well, I know I need my final unit to be in minutes. So I might as well start figuring out what units or conversion factors I can use there. Oh, I know silver has a charge of +1. I know silver has a molar mass. Well, let's start with one of those. So let's go ahead and go to moles of silver first. So what I'm going to do first is I'm going to divide by the molar mass of silver. 107.86 grams of silver for every 1 mole of silver. This gives us moles of silver on top. Then I know that every 1 mole of silver requires 1 mole of electrons. So that's a 1-to-1. 1 mole of silver to 1 mole of electrons. That gets me in moles of electrons. Then, because again, we're talking about going to coulombs eventually here, I can use that Faraday's constant, that 96,485 coulombs per mole of electrons to cancel the moles of electrons. And I know I ran this cell at 3 amps, which is 3 coulombs per second. So that's going to get me seconds at the top. I want minutes. So all I have to do is divide by 60 seconds for every 1 minute, and boom, sure enough, I have minutes at the end. Multiply across the top, divide across the bottom, and I get 12.07 minutes that I would have run this cell at to deposit 2.43 grams of silver. Again, it's all dimensional analysis, but it's hefty. If you track your units, you'll be fine. In our final practice problem, we're going to do one that's a little bit trickier because the final unit isn't necessarily something you've come up against before. In this one, we're looking for the charge of cobalt ions that were in the solution when the electrolytic cell was run. The actual unit for charge can be thought of as moles of electrons per mole of your metal. In this case, it would be moles of electrons per mole of cobalt. So that's the unit we're actually looking for. That's our target unit, moles of electrons per mole of cobalt. Here I have a system that's run at 2.5 amps. That's 2.5 coulombs per second. And it's run for 240 minutes. So I can convert from coulombs per second to total number of coulombs by multiplying by 240 and by 60. This is going to give me just the number of coulombs transferred. I need cobalt. So how many coulombs per mole of cobalt? What I'm now going to be able to do is multiply by the molar mass of cobalt, 58.933 grams of cobalt per every mole of cobalt. I know I deposited 10.99 grams of cobalt, so I'm going to divide by that. And then I need moles of electrons. All right, that's going to be at the top. So I'm going to divide by 96,485 coulombs per mole of electrons. I've canceled everything else out. And all I'm left with now is moles of electrons per every 1 mole of cobalt. Okay, that's our unit of charge. In this case, the charge is +2 because I've multiplied across the top, divided across the bottom, and I get a charge of +2. So that wraps up today's video. Today was stoichiometry. Let me tell you, this is the hardest stoic you're going to do all year. Okay? Dimensional analysis using as many steps as we use in electrolytic cells is the high end of difficulty. There are a lot of units, a lot of constants, and a lot of times the roadmap isn't necessarily laid out for you. Again, going back to my original trick that I recommend is start with whatever unit you want to finish with at the top of your first step of dimensional analysis. You don't have to do that in the end. Also, if you happen to do dimensional analysis and realize that your final unit is on the bottom or upside down, inverted, don't worry. All you have to do is do 1 over that answer and you'll get the correct result. It's all coming back to tracking your units, though. Track your units. Don't be lazy. Write them down, cancel them out, because if you do that and do it appropriately, you're never going to get the wrong answer. Today's video was written, directed, produced, and edited by Abby Law and Annie Kelleher. Thank you so much for watching it. I hope you enjoyed it, and I'll see you in the next one. Sweet!
Is the recap
Assist. Today's video was written, directed, Proust. Nothing like a little Proust, right? A little literature coming at us. Anyways. All right. So a quick review of the we've got the Friday giggles going on here, people. I know what's going on the blooper reel. And that's where we went off the rails, people.